Welcome everyone, this is episode 25 and today we're going to be working on themes and turn order. We need themes for the turn order because I'm going to implement the classic system where first one team gets to act and then the other team gets to act, instead of a system where the turn order is determined on a per entity basis. So it's more like the system used in a game like Vandal Hearts than the system used in a game like Final Fantasy Tactics, for instance. So let's get started. So the first thing we should be working on is getting some themes, and well, we don't have any yet, so we can start creating some tests about themes. And we can say that a new entity does not have a theme. Okay, so let's create a new entity. Add a position, and let's assert that the entity has a theme and it's empty. Okay, so this doesn't compile because we don't have that variable yet, so let's create one very quickly. And let's build and run our tests. Let's see. Okay, so test passes now. That's cool. Of course, nothing really changed because we're just setting. Still don't really have a theme variable yet. So let's try and take it one step further by setting that we can set a theme for a new entity when passing in a theme. So let's create another entity. Entity, and we'll create a starting position at 0. But this time I also want to pass in a theme. A theme. And then I want to assert that our entity's theme is the A theme. So first let's make sure that this compiles. Let's do so by allowing the option to pass in a theme. And now this should compile. However, when we build and run the tests, they don't succeed. Because we need to set to theme, meaning that this now becomes a string instead of a hard-coded value. So let's run test again, and let's see. I would have expected it now to pass. Oh, there's a typo here. And now it passes. Okay. Let's use this theme in our UI so we can see the theme name for an entity. So in our entity view, let's see, here it is. We have a label for our sprite's name. Let's also add the theme name. So and let's make sure that in our view model, now it's in our content view, we also set some themes. So here's our content view. Let's set our knights to theme AI. and our rogue to team player. So let's see, so we can now see that we have a knight in AI and player as a team for the rogue. We need to add a closing bracket here to make sure that we also see them on the screen. So that looks a bit better, but it's really a small fix. So we have now associated teams with entities, but we're not doing anything with them yet. But we're going to be using those to create turn orders. And to do turn order, I'm going to introduce a new abstraction called a battle. And the battle will keep track of both the state of the battle, so is it still undecided? Did one of the two or more teams win? Which is the current team that's whose turn it is to act? Which entities are in the team? Those kind of things. So we should create a new file, a new Swift file called battle.swift. And we also need a new set of tests. So we call this battle tests. This requires exit test and a testable import of ISO tutorial. Then we can create a new final class battle tests that conforms to exit test case, and we can start running our first test. So the first test I want to create is something like test a battle has teams based on entities passed in. So this assumes that I can do something like, let's create a battle that has some entities, and this will pass in an array of entities. Let's create a couple. And this will be an entity at 0, and the team will be player. Something similar. That will be the second one. The third one will be an on AI, team AI1, and the fourth one as well. And then we will have a fifth entity on team AI2, and the sixth also on AI team 2. So we have this array of entities now. Let's create a final class battle that has a set of entities. And then initialize, so this one now should compile. And then we can assert that the battle.teams, so we should be able to get all the teams in the battle, that these are player, AI1 and AI2. So let's implement this teams variable. This will return an array of strings. For now we can return an empty variable, so this one at least compiles. We run our tests. And this one obviously fails. So let's do this a bit. Let's start implementing this one. So let's first get all the team names. We need the entities we have, so we can no longer not have our entities in the battle. We need to store them, so then we can map them to their teams. So now we have an array of all team names, but those might contain duplicates. Then we say we return the team names, we reduce into an empty array of strings. Let's see, this gets in a result and a team name. And we do then if result contains the team name, so if it's already there, or it's not already there, then we append the team name to our result. Let's see if the test now passes. Okay, so it passes. So now we have our teams in the battle. Let's do a second test. Let's say that when the battle starts, so at the start of a battle, the first team is the active team. So the first team in this array will always be the one that's whose turn it is at the start of the battle. So we should have and get some more entities and a battle. And then we can assert that our battle.activeTeam is equal to player. Let's implement this variable. Run the test. See it fail. However, if we return teams first or an empty variable, I think that should be enough. Then now this test should pass. Okay, cool. Next test. Well, before we do the next test, let's refactor this a bit, and I'm going to need these entities a lot of times. So I'm going to call them example entities, and I'm going to use them here and here. And I want to get rid of this stuff, so the tests become also a bit shorter. Okay, so next test proper. How do you go from one team to the next team? Well, I think it makes sense that the next teams should be up to act if all the entities in the previous teams have already acted. So I could say something like, if all members of the active team have acted, then the next team is the active team. So again, I need a battle. Then I should set entities to have acted. So I should be able to do something like battle entities 0 has acted to true, and the second entity as well, because these are part of the same team. So if I now assert active team should be AI1, because that's the next one. However, entities don't have a has acted value yet, so let's implement one of those. So let's see, we have our entity. Let's create a variable called has acted and we'll initialize it as false. So now it can be set to true and we should be able to run the test. And the test fails because the active team is still player and not AI1. So we need to do something with the active team variable. This needs a bit more logic. We will do this slightly different. We now take the first team, but we'll do it a bit different. We'll take the first team where an entity has not yet acted. This way, this needs to be our entities. So this way we take our look for each entity one by one, and we take the first one that hasn't acted yet. So for instance, let's say this one acted and this one not yet, then player is still the active team. Otherwise, if they both have acted, we fall through to the next one, and that's in this case AI1. So this test should now pass. Okay, so we have sort of a turn order already. We can go from team to team. But what happens if all the teams, if all the entities have acted? In that case, there wouldn't be an active team. I assume that at that time the first team becomes the active team again. So we should test that if all members have acted, then the first team is the active team. So again, we need a battle. We set all entities to having acted. And then we go through each entity in our battle.entities, and we assert that entity has acted is false. So let's build and run. And this test fails because they have all the flag has acted set to true, and we're never setting it to false. So how can we do that? One way is we could call some form of function to that resets these values. I think it would be cool if this is more or less automatic, and to do that I'm going to first hide this internal state. So I create all these entities. I make this a private variable. And then I create a computed variable called entities that returns the entities. This should now again build and run. Oh, these ones shouldn't have changed. This should have been only a local change. Let's see if this now compiles. Okay, so it compiles. The previous tests pass, but this one doesn't, just like now. And instead of only returning the entities first, I'm going to do a check for the next turn. So I can do a private func check next turn, and that checks if entities filter has acted is false. If this one is empty, so there are no entities that haven't acted yet, I'm sorry for the double negative, then we go through each entity and we set entity has acted to false. So this resets them all. Let's see if this now passes the test. And now the test passes. So now we can have all entities act, and then we get back to the first team to act. And let's verify this for a bit. Oh, we're not. Let's see, we exert that they all are have acted. This is actually a slightly different test, so I'm going to rename. Well, I'm first going to copy this test because I think it's a valuable test. But I'm going to rename this one first. So then, if they all have acted, then all entities have acted set to false. That's what we're testing. And here we should assert that, again, the active team is the player. So let's run these tests. And let's see. So this one fails because active team doesn't do the check for the next turn. But a quick trick to fixing this. If we call the property, then we go from here to here, and then we do the check next turn. If we do this, then this one should also pass. Right. So now we have a turn order. Let's see if we can make this slightly more explicit. So we have our content view. I don't need the canvas. I don't need this one for a bit either. So we have a content view. The content view creates a state model. In the view model, and I would like to show the current team on screen. So let's say we create a text here that says current team. We should have a view model battle.activeTeam. The view model doesn't have a battle yet, so we'll add it in a bit. So let's go to our view model and change it up a bit. Let's see. We should have a battle. And we can create the battle as a new battle based on the entities passed in. And let's change our entities to a computed variable that just returns battle.entities. Let's see if we can run. So we're building. And now we can see we at least have the current team set to AI. But AI isn't doing too much yet, so we need to find a way of making sure that these entities act and then the next thing happens. Also, I think I can still control them, but whatever they do, they don't end a turn at any time. So we should make it so that doing certain actions ends a turn. Meaning that an action should, after doing an action, the turn should end for that specific unit. So let's go to our entity tests once more, and we have this complete actions part where we have tests related to completing actions. This one requires, I think, a couple of new actions. So one test we can do is test complete current action sets has acted to true when current action ends. Well, when the current action is done. So we need an entity. At a start position, we need a current action. Can be a dummy action. Then we call entity complete current action, and then we assert that entity has acted is true. So let's run these and run this test. And the test fails. So let's once again look into our entity class, and in our complete current action, let's just make sure that we set has acted to true. And let's build and run. Okay, so the test now passes. However, there is a bug in doing it this way, and the problem is that if you let's see if I can demonstrate in the game. So let's say I move my knight here. It takes a bit of time to move. First, let's make sure that we can also see in the entity view if an entity has acted. So let's say has acted. This one can be red, I don't know. Let's build and run. So now we can see that this one has acted is false, has acted is false. So, and this one has acted as false, so let's move. Let's attack the knight, and now the knight has acted to true. And the reason is to show the hit animation, we let this one perform a hit take damage action, and now the take damage action is setting has acted to true. So basically it's sort of impeded in moving, and that's not what I want. So I need to some way differentiate between various actions on whether or not these should end the turn. So of course we can write a test for that. So let's say we have a test that says complete current action does not set has acted to true when current action does not end turn. So let's see. So we need a dummy action that does not end turn. That's an action. Then we need an entity. We can just use this one to conform to the protocol. Then we have the entity's current action set to a dummy action that does not end turn. And we say entity complete current action, and then we assert that entity has acted is false. So let's build and run, or at least run the test. Okay, the test fails. So let's go into our action and let's create a new property called in the protocol. Let's create a new property called ends turn. That's a boolean, a read-only variable, and let's give it a default value. We assume they should normally end a turn. However, now I can set this one to end turn to false. This doesn't solve it yet. But now I can go into my entity and go into complete current action, and I can do a slightly more sophisticated thing by saying if current action ends turn, and we'll set default this one to false if current action is empty. Then we set has acted to true, and if we now build and run this test, it should pass. Okay, now another test fails. Which one? Oh, and we can only set current action to nil afterwards. So that's why it's so cool to have all these other tests as well. Now all the test passes. Let's check if our take damage action actually does not end the turn. So let's go into our action tests. We have arranged the tags. Let's create a new mark for take damage action, and then func test take damage action does not end turn. Let's create an action and we assert that ends turn is false. Run test. And test fails. But if I go into action to our take damage action and I set ends turn to false, run the test again, this should now work. Okay, so some actions now end turn. So let's see. So let's, for instance, move our knight, and let's move this knight as well. Now they both have acted. Hey, now the player. It's a player's turn. And I move the player. And it's no longer the player's turn. However, it still looks like this because the view doesn't get updated. So let's, for instance, click here, and then the view updates, and we can see the correct effect. So we have sort of turn order working. What I want to do is I want to clean up at least the fact that the view doesn't always update fast enough, and I'm going to use, I'm not sure if it's a hack, but at least it's something that works very well. I create a new published variable called redraw count, and I set it to 0. And then we need to make sure that we, in the game scene, where's our game scene? Each time we redraw, we can take our view model and increase the redraw count. This sort of forces an update. So now if both have moved, now we can see the current player is up. Notice that we can still control the knights, even though those are AI players. So I think what we should do is make sure that we can only control our player. So let's go into our entity view. And where's our entity? Oh, I'm sorry, the entity view. Get rid of this one for a bit. We have all these buttons here. I only want to show them if the entity hasn't acted yet. So it shouldn't be, the current action should be nil. And we should make sure that our entity has acted as false. And we should make sure that our entity.team equals player, and also that our view models battle.activeTeam is the player. So it should be the player's turn. This should be a player entity, and it shouldn't have acted yet, and shouldn't also have, we shouldn't be creating a new current action. So let's see what the effect of this is. So now, well, we can't control anything yet because it's an AI turn and the AI isn't doing anything. What I will do is I'll create, we can of course automatically have the AI do something or choose to do nothing at all, but I'm going to make it really explicit. I'm going to, in the content view, I'm going to create, sorry, after the current team, I'm going to say if the view model battle.activeTeam is not the player, then I'm going to create a button, let enemies act, and if it's pressed, then I'm going to do the entity in view model.entities, but I'm going to filter because I only want the ones that are not for the player. So I'm going to take and check where the team is not player, and then I'm going to take this entity and set its current action to a dummy action, and then I'm going to call the redraw function on the view model, and I'm going to give this some styling, a button style, and it will be a bordered prominent button style. Let's build and run. So let's see, so it's currently the AI's team. We can let the enemies act. Now it's the player's turn, so let's move to our player. Oh, no, but the player's no longer allowed to act, so let's have the enemies act again. It's again the player's turn, the player can attack. And we indeed can see that the knight also loses some health. Okay, I think this is enough for now, because it was quite a big, but we did quite a lot. We created teams, we created a battle to associate all entities into the determine turn order. We added ending or not ending of turns to actions and made sure the entities are able to use them. And we all wired it up in our UI. So I think that's a good result for now. You might play around with the game and notice that currently HP can go into negatives or 0 and nothing happens. What we need to start implementing is death. And from that we can also determine if a complete team has been eliminated and in the end who won the battle. And that's what we're going to do next time. So we're going to look at the battle state. Is it undecided? Did any of the parties win or not? And we're going to look at defeating entities and what happens then. So thanks for watching and have a good day.